Alrighty, in this video we are going to be talking about trig equations in terms of finding the general solutions. So remember that the period is going to be the distance before repeating the trigonometric graph again. Now remember that sine and cosine and its reciprocal will have a period of 2 pi over b, and then tangent and cotangent will have a period of pi over b. And that's going to be important whenever we talk about adding something again and again and again to get your general solution. So for more in-depth detail, probably look at number 7 and number 8, because for number 7, whenever we restricted this from 0 to 2 pi, we had more answers instead of just stopping at 0 to pi, because that was my period here. All right, so for number 9 through 14 here, we're going to find the general solution. Number 9 is 2 sine square of x plus 3 sine of x plus 1. And it's very similar to what we did back in number 4 here. So use the same method that we did in number 4. And see what we come up with in terms of solving this. AKA factor this. I'm going to, not show you the work, but hopefully we know how to factor this. So we get 2 sine of x plus 1 and then sine of x plus 1. I'm going to go ahead and make a table just so that we know what's going on and I can distinguish what is going on. Wait. Make a table so that I get sine of x is equal to negative 1/2, and then sine of x is equal to negative 1 whenever we solve the equation for each factor. We know that sine of x is equal to 7 pi over 6. And we also know that this is equal to 11 pi over 6 whenever we get to negative 1/2 here. Likewise, for sine of x is equal to negative 1, we get 3 pi over 2. Lucky for us, because we don't have an argument that's not something like 2x or 3x, my period is just going to be 2 pi. So I'm going to write this as 2 pi k, where k is an integer. So then just denote that k is an integer. And you're done. Likewise, with number 10 here, what we are going to do is go ahead and probably rewrite secant square of x so that it has tangent in it. So we get 1 plus tangent square of x plus 1/2 tangent of x is equal to 1. The ones will cancel out. So we get this lovely thing right here. And then we are going to go ahead and factor out a tangent. And then we are going to make a table for tangent of x is equal to 0. And then tangent of x is equal to negative 1/2. Now you probably saw on number 8 right here that whenever we did inverse tangent of negative 1/2, this right here was not our answer because this was negative and it wasn't in our domain of 0 to 2 pi. Because that's the case, in this one right here, we can include inverse tangent of negative 1/2 now because we're finding the general solution. And remember that because this is tangent, our period is going to be pi over b, or just pi. So whenever we solve this, tangent is 0 at 0 and pi, which should make sense because my period is pi. So I'm going to say x is equal to 0 plus pi k, and then x is equal to inverse tangent of negative 1/2 plus pi k. where k is an integer. All right, so same thing with number 11 here. We have a square. So whenever we take the square root of this, make sure that you have plus or minus 1. So then we get sine of x is equal to -1, and then sine of x is equal to 1. Sine of x is equal to -1 at 3 pi over 2. My period here is just going to be 2 pi k. Same thing here, sine of x is equal to 1 at pi over 2. And then my period is just going to be 2 pi k. And you'll just call it a day. Now, number 15, though, this is where things get a little bit wonky because we have a square. So we're going to have to take the square root. And then we have an argument of 2. So we have a b value of 2. Now, having this b value of 2 is going to tell me that my period is going to be pi. So instead of adding 2 pi k every time, I'm going to be adding pi k every time. Or so we think. I'm going to go ahead and probably simplify this down a little bit so that we get sine of x is equal to plus or minus root 3 over 2. So that is just going to be the pi over 3 family. So we have, I should probably rewrite this as u's. So the pi over 3 family is pi over 3, 2 pi over 3, 4 pi over 3, and then 5 pi over 3. Now, because u is 2x whenever we did our substitution, even though I didn't really tell you that, we know that x is now going to be pi over 6, pi over 3, 4 pi over 6, which is 2 pi over 3, and then 5 pi over 6. So that is my solutions from 0 to pi, because that was my period. But remember that since I'm asking for the general solution, I'm going to have to plop a plus pi k on each and every single one of these. So then we're going to get pi over 6 plus pi k, pi over 3 plus pi k, 2 pi over 3 plus pi k, and then 5 pi over 6 plus pi k. Now, we have 4 answers. This, it's okay. You have all of the answers. It's fine. Yippee, hooray. It's there. Now, here's the thing about this one right here. If you really think about where pi over 3 is, 2 pi over 3, 4 pi over 3, and 5 pi over 3 is. Let's probably start with, let's say, my distance here. So going from pi over 6 to 2 pi over 3, or pi over 3 to 4 pi over 3, gave us, let's see, this is 4 pi over 6. So this is pi over 6. So this gave us pi over 2. Which should make sense because this was pi. And then since we did use substitution, we'll get pi over 2. Likewise, if I did it here, we'll get a distance of pi over 2. So instead of having 4 solutions, which eventually it's going to repeat itself, we might as well have 2 solutions where we have all of the solutions with those 2 solutions. So I'm going to say pi over 6 plus pi over 2k, and then pi over 3 plus pi over 2k. So let's visually think about this in terms of the unit circle again, from pi over 3 to 4 pi over 3. Now remember that pi over 3 is like right here. And then because my other solution was 4 pi over 3, which is right here, notice how this here was a distance of half of a circle, which was pi. But because we did use substitution, we had to divide by 2. So then our thing now became pi over 2. Likewise, this was 2 pi over 3. And this was 5 pi over 3. My distance from there to there is pi, which means that my distance from here to here is pi over 2. So this will work if and only if you have a square and you have all 4 solutions of your family. So if you had, let's say, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, we'll get the same thing. Now, with pi over 4, that's going to be a little bit different because your thing is pi over 4, then 3 pi over 4, then 5 pi over 4, then 7 pi over 4. So what's so special about this one here is that with your 4s, we're just adding pi over 2 each time. So technically, we have a very more stricter answer, because technically you could just use 1 and then add pi over 2. We'll see if we get more examples. No, probably not. But we'll probably do more examples of these where we might have 4 solutions and see what happens there. But let's look at 13 and let's look at 14 here, because 13 is a tangent. And notice how your b value here for 13 is 3, which means that my period is going to be pi over 3, which means at the end, I'm going to have to do plus or minus pi over 3k. I'm going to go ahead and subtract tangent of 3x. And then I'm going to divide by 2. So I get tangent of 3x is equal to -1. Now, hopefully we don't have to use substitution here because we know when tangent what we are. But theoretically in our mind, we know when tangent is -1. That's going to be 3 pi over 4 and 7 pi over 4. That's going to be our u. But then we have to divide by 3 now. So then we'll get pi over 4 and then 7 pi over 12 as our initial answers. And then, of course, because we have a period of pi over 3k, I'm going to add pi over 3k. And this right here gives me my final answers. All right, last one. Number 14. We have secant. That's okay, because remember that secant is the cousin of cosine, so that's just going to be 2 pi over b. I'm going to do 6 secant of 4x is equal to -4 root 3. I'm going to divide by 6, which gives me -2 root 3 over 3. Now, we don't have that, a -2 root 3 over 3 on the unit circle. Well, that's because it's a secant. So what I'm going to do here is go ahead and probably do cosine of 4x is equal to 3 over negative 2 root 3. Now, most likely we know that this is going to be a unit circle value. So if you think about 3 and 2, this will most likely going to be negative root 3 over 2. But let's probably verify that's true by multiplying by the conjugate so that we can see that it actually works. So we have, so then we get 3 root 3 over negative 2 times 3. The 3's will cancel out, and ta-da, you get negative 3 root 2. Okay, so now let's think about when cosine is negative 3 root 2. Cosine is negative 3 root 2. Let's see. Well, if you're pi over 6 family, but because it's negative, it's on the left side. So it's in quadrants 2 and 3. So you'll get 5 pi over 6 and 7 pi over 6. But then we have to divide by 4 to get 5 pi over 24 and 7 pi over 24. And then, because my period is 2 pi over b, aka 2 pi over 4, aka pi over 2, I'm going to add pi over 2k into my solution. This gives us our answer. All right, so that's it in terms of unit 0. And then you have our quiz. Yay!